this is not error, okay? This is a warning. And there are few participants asked me about this. Let me clarify this. What is happening is while installing TensorFlow or NumPy, I am using a generic library that is compiled in different machine and different OS environment, not like particular version of this Ubuntu or particular Intel CPU of this i5, i7 or whatever Intel. And here it is all about that. And what it says is if you compile instead of just grabbing those library from the repo, if you compile on your machine or if you download the machine specific version, it will be more faster. Okay, that is what this tool is, this message is saying all about. If the information is here. And especially if you are little computing background, you will know that there is a SIMD instruction in every CPU. That means SIMD instruction and how to collect instruction and how to do the calculation. That is called SIMD. Or there is a GPU also somewhere. Sorry. GPU also somewhere. Sorry. Yeah. Similarly, if you have GPU laptop, like mostly a gaming laptop has GPU, on that case it runs 1,000 times faster. And we are not able to harness that power of the GPU, and that information will also come here if there is GPU in your laptop. Okay, so this is not error, but it is a suggestion. And now I am reading a diabetic, mostly Madhumeya in Nepali or in Hindi or Sanskrit. Madhumeya means or even in English. Okay, diabetes. And diabetes in this, although headers are missing in this data set, so I am putting myself manually as a comment. Pregnancy, glucose, the first is a skin thickness, insulin, BMI means body mass index, and diabetes, medical order, and age, and last the outcome. Outcome is 0 diabetes. If outcome is 1, that is a diabetes. Okay, we will see the database just now. And here also, and while you reading this file by the NumPy, then you have to write the delimiter. Delimiter means how you are separating your field by the comma. So you need to declare it here. Okay. Now I am reading, and let's read the same file by a terminal. Let me go back to terminal and so this is the diabetic file. Just so, for example, possibly as I assume the first column is the month of pregnancy. No, it is not. Week. This is the week of pregnancy. It cannot be month. And second is according to that headers. Okay, the header file is missing on this and directly starting with value. So in this case, NumPy is useful to read. But if you read with Panda, it is better to include a header as well. So this is the data set, and let me check how many points are here. So this data set contains 768 lines of results, observation. So this is also typically reliable data set. It is 1/4 to 1,000, right? So this is reliable data set, like concrete just before we did. Let's go back to the board. And now I would like to split the data set. And here also I am taking same strategy, 2080. And model is slightly different here. Although splitting is also different, because it is a different kind of data set. I am going to do binary classification, whether she has diabetes or not. Okay, and this data set is collected in Native American women who are between the age of 21 to 50. Okay, so there is documentation also about this data set. And this is little bigger model, although you can make it smaller. For the purpose, let me cut down some way. I will cut from here to here or this one. So I am done. Or you may not cut, okay? Anyway, I saved it. The most important difference is the last stage of the model. Here output is still 1, but the activation function is sigmoid. And what is the character of sigmoid? If it is on the left side, it will asymptote to 0. If it is on the right side, this will asymptote to 1. That means yes or no. So this is the function we need for binary classification. And we can somehow use 10 hyperbolic also. 10 hyperbolic also has very similar character. Okay, and instead of sigmoid, you can play on other binary functions such as 10 hyperbolic. Let me run the module. There is no error. Now I need to compile, and this compiling is slightly different than earlier. And here I am including loss function is binary cross entropy. Instead, that is one addition, and optimizer is same, and matrix is accuracy instead of EMAE before. Mean absolute error instead of mean absolute error. I am organizing differently. I am handling my error differently here because of the binary is we work in this way. So there will be no error obviously. And my model is very good right now because, and in this case, I am leaving the Bath normalization and dropouts are included, but I am not including early stopping criteria here. Okay, that is somehow not relevant for binary part. And model that fits x, y, instead of x train, y train, I am just putting little lazy, capital X and small y generally, okay, to distinguish them. And batch size is 1024. It is very reasonable value because my data is close to 1000. So I can read all the value in single sweep, that means. And my epochs are 100 and verbosity is 1. Okay. And although I forgot to delete the calculation, but let me do it again. So it is running, finished running. Actually, here is white.com. What happened? The error is slightly higher. Okay. The error is around 0.5% while learning, and accuracy is 76%. So now this helps doctor, medical person to estimate. Now medical person will fit all the previous features of the patient and run according to this model, but his decision is only 76% correct. Okay. So what I want to do is either I have to include more data sets, which I do not have at the moment. But what is the other option? You increase the epochs, means, or you improve your model, that which lines I deleted previously, that might have effect on the accuracy later on. Okay. At least for now, the easiest way is, let me do it run to for 500. It doesn't take much time. So rerun the model again. It might take around 5 times this, but just 2 minutes, 3 minutes, I guess. Very good. Yeah, finished calculation. Let's see whether I have improved my learning. Wow. Learning improved really high. Although I increased the epochs to 5 times, and I can commit this much cost. Okay, I can afford this cost. Loss is 1.16%. Okay, and accuracy is 95%, very closely, which is far better than previous model. So now this model will work very good. Then doctor can give medicine of start medicine of the diabetes to the patient out of according to this model. Although it requires close medical supervision, but as a deep learning perspective, we are good. Any model beyond 75% is considered very good basically. But now our accuracy is 95%. So if we are little crazy and increase this further 1000, let's see what will happen. You can also do with me, okay? Let's increase to 1000 and see what will happen. And instead of scrolling, just see this black circle, okay, here. As long as the circle is black, calculation is running. Once it is finished, it will go to white, and then we can scroll down once. It's going on. Calculation, yeah, my hand is going. Yes, finished it. This is not good. This is actually not good. Now this is a numerical fatigue. This is the case of numerical fatigue. Before it was up to 98%, just few minutes before, few epochs before, and later on, performance decreased to even 53%. It's a fatigue. So tired that he even couldn't read correctly because of sleepiness, drowsiness, any other things. And more or less, he maintained the 76%, which was just before like 100 epochs, answer of 100, accuracy of 100 epochs. Okay. But here, if I run that code, actually it is 71%, which is not very good. Okay. This is how the binary classification works. And I will not stop here. There is one more remaining. If there are 3 items, how to classify? If you know the classification of 3 items, then you can do items. Okay, in Sanskrit there are, if you know the Vachan, do you know Vachan in grammar? In Nepali or in English, there are only 2 Vachans, singular or plural. But in Sanskrit there are 3 Vachans, Ek Vachan, Dui Vachan, Bau Vachan. Okay. So this deep learning algorithm goes like a Sanskrit language. Classification, define the like quality of white wine, that is single, Ek Vachan. You are predicting only one value. Now you are predicting 2 value, yes or no. Okay, that is 2 value, Dui Vachan. And if now next is Bau Vachan, means multi-category. Okay. And if we explore the again folder, there is somewhere multi-class, this file right here. So with this, basically it is a complete deep learning package I am able to deliver you. So let's see, and it has obviously slightly different coding of style. Let's see, and obviously this has more complex because Bau Vachan is always complex. Pandas, as I am back to Pandas now, and TensorFlow is all there, and scikit-learn is also I am including, which I was including before as well. Okay, so this is the model, and all other flows are basically very similar. You read the data using Pandas library, and here you have to transfer your value, that object, into a vector. Okay. Suppose you have 3 kind of color, doesn't understand and cannot involve in a calculation with color. So you have to convert that name into a number so that it can involve in computation. That is called encoding. And you have to come back and decoding. So this is the idea we play with the objects. Because object we cannot directly play in a numerical way. So that telephone number is an object. Although it is a numerical value, but it has no numerical value. We cannot add or subtract or divide telephone number. Okay. So that is the object. and you have to like my telephone number is one value, numerical value, and Arun sir is one, and principal madam will be 3, 4, and so on. So we have to encode that telephone number in a value, and then once we play with those numbers, and then come back and decode the and get the original telephone number. So temporarily we store that as a number with a different way, and that is called encoding. And again we will back to that number by a decoding, and we will to the actual object which has no numerical value again. This is the style we will implement here for multi-class classification. And let me show you the iris flower here. There are 3 kind of rows iris flower according to their size, color, shape. They have different names. Let me show you the data set, and obviously I can run it here instead of showing. Okay, I got error. We did not define. Did I run it? Okay, I forgot to run the header. Okay, that's why I got error. Sorry. Yes. Okay. Now I will teach you one important thing. You have a scratch also in Notepad. Scratch. So scratch can be obtained by this plus sign. Click here and a cell will pop out like this. So I just want to, my data is, what is my data here? Data set, right? Data frame. I am just doing data frame head. Do this thing. Let me do it and try to figure out what are the top 5 values of this thing. So 0, 1, 2, 3, 4, and 4 is the category. In the 4, suppose its size of leaf is 5.1 centimeter, or flower size is this, or any other property size is this, and another property size is this, then this flower is iris setosa. If you are from botany background, you will understand this very well than me. So this is a botanical, and iris setosa. Although these all are iris setosa, let me see a little bit more. 20, so that there may be looks like all iris setters are here. Which one? Yes, it's, yeah. Let's see which tail. Yeah, iris virginica. There is one more type of flower. Okay, and these all flowers are, I know. At least we saw the 2 types, but 3rd type maybe in the middle. We can read the direct CSV file and figure this out. Okay. Okay. Let me remove this now because I finished my script and I will remove that cell. Now the next part, important part, is the encoding, the last column, because it has no numerical value, so we have to handle it differently, as I said earlier. Okay. I think I forgot to run this cell. Label encoder. This is the standard function in deep learning libraries, and now I will encoding dummy as a dummy variable, and define the new model. Model definition is now working as a function. Before I was plainly defining a model, but here I am defining model as a function, baseline model as a function, and it has all these things, and I am compiling. This is sometimes very convenient and more modular. If you want to use this function in another program, you just call this baseline model and you are done. You don't need to define on the other case. If this file is right in your same folder, or give a path and call this as a function, so it is more modular way. Okay, so okay, and here what I am doing is model is equal to sequential. That is the same thing as we have done already. And in the first line, I have 42 neurons, and my input size is 4. Because 4 is that flower has 4 features, and the last line was the category of the flower. Flower, and there is another sort of flower and another sort of flower. Now what I will do is from 0 to 1.9, if the value is 0 to 1.9, that is one kind of flower. From 2 to 2.9, that is another kind of flower, and above 2.9, another kind of flower. So I am giving some numerical value, and softmax will check that range basically. If it is smaller, then value is this. If it is greater, then value is that. So this will kind of decision making part is during the softmax, perform at the softmax. So let's see, and it will return the model. So this as a function, we have to return value to the function, and compilation is done right inside the function. Okay, it is this before there were 3 lines of this previously, but now I am writing a single function embedding all those materials inside. Okay, let me run this, and now actually training is performed in this line. Hit the model. Now my model is called estimator. The model of this particular is called estimator, and Keras. And here is I am generally I was doing model.fit before, but here I am doing differently. Okay, Keras classifier is the right thing for this, right library for this function, and build FN baseline model. That is the reason I define my whole thing as a function, because I will call inside the classifier that function, that value. And epoch is equal to 100. Obviously, you can increase to 300 because our laptops are powerful. And batch size as 1024. Let me see the data size. How I missed that word. There are 150 lines. Okay, so my sample size is 150 in this case. So if 150, then I think this is overkill. 256 is the closest number to handle this many data. Okay, it is still a one swing. I don't need to even go 1024. So let me model this. Is this either or no? I think no either. Okay. Yes, now it is performed. Okay, now next is this is warning. Okay, not a error, don't worry. And evaluate the model with k-fold cross validation. Now this is entirely different than we have done before. Here it will examine the classes that learning for 10 times. 10 times the code will run. That is the k-fold. What is the meaning of k-fold or n-fold? It will do that many times. That is called fold. Okay, and it will again shuffle that data of 150 line data. Those rows it will shuffle differently for each round. So this is a very robust kind of training, because we are increasing more randomness on this training than previously. And this is exactly the autonomous car will also work. This is the basic background of autonomous car. How do a car recognize a road and people walking and slightly change direction? This is it has to classify those objects and apply the brake, move turn the steering, everything it has to do. Or if there is light condition is low, it has to turn on the headlight. Okay, so there are so many things autonomous car has to do, and this is the basic block of that one, foundation of that learning. And it will take little time because it is running the same code 10 times. And we can check this. Suppose how it is repeating, I will show you. Now my epoch is 300. Okay, and let me see it has repeated. Let me show you how it is. Otherwise, it should stop after 300, but it is not stopping after 300. Let's go down and see the evidence. After 300, it began another calculation. Okay. So since my calculation is 10-fold, it will repeat this calculation 10 times. So it is little bit compute intensive, and after this, I will show you how we can change this code from Jupyter Notebook to Python and run on the supercomputer. That is the next part. Maybe we might have some small break. Let us take some small break. First, let us see the result, and then we will take break. And then all of you might have already got your supercomputer ID. So password I will tell on a offline session, because other unwanted people might also get access if I tell on the recorded session. So I will tell you on the tea time, okay, password. So it is going on anyway. Calculation is going on. Let's wait for a while.
Loss and accuracy. You are saying that, let's say any number, let's say 150 times you are three.
Yes, yes. This one. Yes.
97%.
Yes, yes.
And loss is 21% or 8.2%.
Generally, when you say loss, it is the loss of learning time loss. And when you say accuracy, it is the accuracy of the validation. So it is not 1 minus loss is accuracy. Okay.
Yes, percentage, both are in percentage.
Yes, both are in fraction basically. Here it is a fraction. Yeah.
So let's say accuracy 97% and loss is 21%.
Yeah. Yes. Or if you haven't run, you can decrease the EPOS also, okay? Because even in my i7 processor, it is taking long. Or if you had a GPU and you are able to harness that GPU, it would have run faster, but I'm not going on that direction at least now. No, sir, because that is too much for this time. But I will keep updating the repo, and now I am also on the WhatsApp group, and I will push the message if I do something changes. Okay, and there is obviously it will continue, and sometimes the loss is even going higher. So it's a numerical fatigue in some sense. It's taking longer time.